Welcome back. In our last class, we have already been introduced to set and its different types. In today's class, we will be learning about different operations that we can perform on different types of sets. The first operation that we will learn today is how to find the complement of a given set. Suppose we have a set A where this set has 10 elements from 1 to 10. Now suppose we have another set B where B has 4 elements like 3, 4, 7 and 9. Now the complement of B set with respect to A set will be those elements of A which don't belong to set B. Here we are finding the complement of set B. So the complement of B will be represented as B prime or B dash, or we can represent as B bar, or we can represent as B prefix C. C stands for complement. Now here B has elements 3, 4, 7, 9. So from A we have to see that what are the elements that don't belong to B. So with respect to A, now the elements are 1, 2, 5, 6. Then we have 7 in B, so 8, and then we have 9 in B, so 10. Since A has in total 10 elements and B has 4, so definitely when we are finding the complement of B with respect to A, in that set it will have 6 elements, and those 6 elements are 1, 2, 5, 6, 8 and 10. So B bar or B complement or complement of B will be a set where it will have 6 elements 1, 2, 5, 6, 8 and 10. Mostly when we find the complement of any given set, then we find the complement with respect to a universal set, and that universal set will be given to you, and you already have the idea of a universal set. So suppose the universal set, if it is represented by U or maybe zeta sometimes, and if that set is given as A, B, then suppose E, F, then I say K, and we have another set say M, and that set has 3 elements, suppose B, F and K. So complement of M will be those elements which don't belong to M but we have in that universal set, and those elements are A, then next will be E, and then next will be I. So complement of M here with respect to U will be A, E and then I. The next operation that we will learn in today's class is union of sets. Union of sets, you can understand or you can consider this as addition of two sets. So previously what we have learned here, complement of a set, this is basically a unary operation. Why it is called unary operation? Because here we have a set B and we are finding the complement of that set, and here we are doing that operation with respect to a single set. So it is unary operation. Next what we will be learning is union of sets. So here it will involve two sets. So this operation is called binary operation. Suppose we have two sets A and B, then the union of A and B, this is written or this is represented as this. So in the new set, which is union of these two given sets A and B, the elements of that set will either belong to set A or will belong to set B. So in the new set, which is the union of AB, we can say this way that the elements of that new set, if that is represented by X, then X will belong to either A or it will belong to set B. So that is the definition of union of two sets. Now we will understand this with an example. Suppose we have a set A, where we have 1, 2, 3, 4, 5, 6, 7, 8 elements, and these elements we can see what are they. And then we have another set B, where we have 4 elements, 2, 4, 6, 8. So when we will perform union operation between A and B, then in that new set the elements will come either from A or from B. So first we will consider all the elements of A, and we will write here one by one after another. So here first we have already written the elements of A. Now we will write the elements of B. But one thing we have to keep in mind, that when we will be writing the elements of B, or we will be considering, we have to check whether there was any common element between A and B or not. So if we evaluate that, then we can see that between A and B there is no common element. All the elements are different. So what we will do is we will write, or we will consider all the elements of B. So it will be 2, 4, 6, 8. So the new set, which is the union of A and B, will have in total 8 plus 4, 12 elements. Now we can rearrange these elements according to their value if we want. So in this example, what we have seen here, that in both the sets all the elements were different. So in the new set, which is the union of these two sets, we have considered all the elements. Now in the next example, we will see that there will be few elements which will be common between those two sets. So how to find the new set? Now here we can see here the set A has 7 elements and set B has 4 elements, and between A and B this element is common. 4 is common, and 8 is also common between A and B. So when we will consider the new set, which is union between A and B, in that new sets, for what we will do first is we will write all the elements of the first set. So we will write 1, 3, 4 and so on, all the elements of A one after another, and then we will see what are the elements which are common between A and B. So since those elements have already been considered, have already been written, so we will not repeat them. So 4 and 8, since we have already written, we have already considered, we will skip them, and the rest of the elements we will consider now from the second set. So rest of the elements means from set B it will be 2 and 6 only. So we will consider 2 and 6 only, and this will be our new set, which is the union operation between A and B. I hope this is clear to you, this union operation. The next operation that we will learn is intersection of sets. Now this will be performed between two sets. So this is again a binary operation. Suppose again we have two sets A and B. So, and when we will perform intersection between these two sets, this is written as A, and as if this is an inverted U, so this is the symbol of intersection. So intersection of A and B is written like this: A intersection B. This is how it is pronounced or read. This will be again a new set, and here the concept is the elements which are common between A and B, only those elements we will be considering here. So in the new sets, if the elements are represented by X, so X will be an element of A, that means X will belong to A, and at the same time it will also belong to B. Initially, or in earlier case, when we performed union operation, that was in between these two sets, it was OR operation. So either it will belong to set A or it will belong to set B, means in either of both the sets. In this case, in case of intersection, since we will be considering here the common elements between first set and second set, so here it will be AND operation. So what are the elements which belong to set A and at the same time set B? Those elements will be the elements of the new set, which is the intersection operation between A and B, or between those two sets. Now this will be more clear when we will learn this with a few examples. Now suppose we have again a set A where we have 8 elements and they are written, and then we have another set, the second set, which is set B, and it has again 4 elements. Now what we are doing here, we are performing intersection operation. So A intersection B will be that set where the elements will belong to A and at the same time set B. So here first we have to find what are the elements which are common. Here as we can see, the elements which belong to A and B, all the elements are different, so there is no common element between A and B. That means this set, the new set, which is the operation, intersection operation between A and B, that set will have no element, so this will be an empty set, and we already have the concept of an empty set. Now we will see another example here. Here A, the first set has 7 elements and the second set has 4 elements, and what we can see here that between A and B we have 4, this element common, and also 8 is common between A and B. So when we will perform intersection between these two sets in the new set, we will have these two elements. So this is how we perform the intersection of two given sets. Now the next operation that we will learn is a difference of set. This operation will be again performed between two sets. So this is again a binary operation. Now suppose we have a set A and we have another set B. So here difference of sets means when we will perform the difference, so it will be basically subtraction, A minus B, and the union operation was the addition operation. So A minus B, the new set, will have elements where that element will belong to A, but at the same time it will not belong to B. That means when we are finding the new set, which is the difference of two given sets, then if we are subtracting the second set from the first one, then in the new set we will have the elements which belong to A but don't belong to B. Similarly, if now we subtract A from B, so B minus A, then it will be again a new set, and in that set the elements will belong to B, but at the same time they will not belong to A. And we will now verify whether A minus B and B minus A, they will be the same set or not, and that will be more clear when we will take examples. Now here in set A we have again 8 elements, and set B we have 4 elements, and since these two sets are the same set that we have already considered in previous cases, so we know that in these two sets there is no common element, all the elements are different. So when we will perform the difference between those two sets, first in the first case we are subtracting B, we are taking the difference of B from A. So here in the new set, what we will do, we will consider all the elements of A which belong to A but don't belong to B. And we have seen already here that all these 8 elements of A, they belong to A only. There is no common element. So all these 8 elements, they don't belong to V. So when we will perform A minus B, so we can write all these elements of A. Now when we will perform B minus A, we will subtract A from B. So what we will do, we will consider all the elements of B which only belong to B, and at the same time they don't belong to A. Again all the elements are different, so we will consider all the elements of B. So here we have only 4 elements as B has 4 elements, and A minus B, when we are performing, we are getting 8 elements. That means A minus B is not equal to B minus A always, but there may be cases where these two may be same, but in general they are not same. And we will see another example here where we have a set where we have 7 elements, and we have another set B where we have 4 elements, and again we can see here that these two elements are same or common between A and B. So when we will perform A minus B, what we will do, we will consider only those elements which belong to A only, but not, they don't belong to, they should not belong to B. So here in A we have only 5 such elements who only belong to A, and 4 and 8 are those elements which belong to both the sets. So here A minus B will be, in that new set we will have only 5 elements, 1, 3, 5, 7 and 9. And now next, when we will perform B minus A, what we will do, we will consider only those elements of B which only belong to B, but they don't belong to A. But again here we know that 4 and 8, these two elements belong to both the sets. So what we will do, we will consider only those elements which are unique to B, which only belong to B, and here we have only two such elements, 2 and 6. So here B minus A has, this new set has 2 elements, and A minus B, that new set has 5 elements. So here again we can conclude that A minus B is not equal to B minus A. Now the next operation that we will learn today is joint sets. Joint sets again is a binary operation, because we will perform this operation between two sets. So binary operation. And what is the concept of joint set? It has also another name which is called overlapped sets, or this is called overlapping of sets, overlapping of two sets. So here the concept of joint sets is, if between two sets, if there is a single common element, then that new set will be called as a joint set. So if we have two sets, say A and B, and what we are saying here is we will have at least one element between these two sets, A and B. And if there is a common element, that means now if we take, or if we perform intersection between these two sets. What is intersection? We have learned in today's classes, intersection gives the common elements between two given sets. So between A and B, if we perform intersection, then we will only consider those common elements. So here as per the concept of joint set, we are saying that there will be at least one common element. So if there is at least one common element, then we can say in the intersection, when we will perform intersection in that new set, there will be at least one element. So that means that new set will never be a null set, or it never be an empty set. It will have always at least one element. It could be more than one also. So we can say that the intersection operation between these two sets A and B, which are joint sets, in that intersection operation, that new set will never be an empty set. It will always have at least one element. So that is the concept of joint sets. The intersection operation of a joint sets will never be an empty set. Now we will understand with some examples. Suppose we have a set A where we have 5 elements, 1, 3, 5, 7, 6, and we can see we have another set B where we have elements 2, 4, 6, 8. So first we will see whether we have any common element or not. We have already found that we have this element common, 6, and 2, 4, 8, 1, 3, 5, 7. These elements are different. So since we have obtained only, at least one element between these two sets, that means we can consider these two sets as a joint set. So our conclusion is that A and B, these two given sets, are joint or overlap sets. Now we have another example where the set A has 7 elements and set B has 4 elements. Now we will try to find whether there is any common element or not. We have found that this element 8 is common between these two sets, and we have again 4 which is common between A and B. So we have here more than one element which is common between A and B. So our conclusion will be what? Our conclusion will be that A and B are joint sets, or we can say overlap sets. Now the next operation that we will learn in today's class is disjoint of sets or disjoint sets, or we can say non-overlapping sets. I hope you have already understood that since previously it was joint sets and there was at least one element common. So if it is disjoint sets, if it is overlapping non-overlapping sets, then definitely there will be no common element between A and B. So if we take A and B two sets, so since this time this is disjoint of sets, there is no overlapping, and if there is no overlapping, there will be no common element between these two sets. That means now if we perform intersection between these two sets A and B, since there will be no common element, so result of this new set or this operation, intersection operation, will be what? It will be an empty set. So we have to keep in mind that if it is a joint sets, then there will be at least one element common between those two sets, so it will never be an empty set, the new set. And if it is a disjoint sets, then always if we perform intersection between those two sets, it will be always an empty set. Now we will understand this with a few examples. Like here, set A has again 8 elements and set B has 4 elements. And now if we assess these two sets, then we can see here that these two sets have all different elements. There is no common element. So we can conclude what? That A and B are disjoint sets, and A intersection B will be an empty set. Now in the next example, set A has 7 elements and set B has 4 elements. And what we can see here, that 4 and 8, these two elements are common between set A and set B. So since there are common elements, so what will be our conclusion? Our conclusion will be that A and B are not disjoint sets. So if they are not disjoint sets, on the other hand, we can say A and B are joint sets. So if we perform intersection operation between A and B, that will not be an empty set. So these were the operations that we frequently perform on sets. I hope you have learned the concept clearly. In our next class, we will be learning a new thing. Till then, goodbye and thank you.